lesson today, we'll be continuing on algebraic expressions or algebraic techniques. Okay, so we'll be doing expanding brackets by its name. When you say expanding, the mathematical word would actually be to distribute, right? Just like, I don't know which one to press now. Distribute is a word, okay? So the learning intention is still to simplify algebraic expressions. Remember what we did last lesson or the previous lessons we did, we added, we subtracted, multiplied, and divided them. So now it's also like multiplication, but a different kind of multiplication because we've got a number outside the brackets, and we want to distribute that to each of the terms inside the brackets. Okay, so the distributive law, we've seen that before when we were asked to calculate in our heads some of the big numbers, just like when we are asked to multiply 6 by 23, you can do that in their heads. I won't without a strategy. Okay, so how would you do that with a strategy? You want to break 23 into 20 and 3, because that's what 23 is all about. Yeah, why do we want to break it down to 20 and 3? Because we can simply add 20 and 6. 20 and 6, 20 times 6 would be 120. And then we've got 6 times 3 as 18, and you add 120, and 18 would give you 138. Isn't that clever? Right, so maybe what you want to do would be to trial some of these questions here in the warm-up, right, before you start the lesson, or start with the questions that I will be giving you today, right? So just like when you have 4 times 17, you do 4 times 10, and then add the result to 4 times 7. Okay, so that's how you do the distributive law. So where was I? So what we said with algebraic techniques is algebra would just be an extension of all your numbers. So anything that you can do with numbers, you can do with all these letters. Well, they look like letters, but actually they are not letters. They are what? They are numbers, because all these letters are pronumerals. They represent a number, right? So what do we have here? We've got the distributive law. We would want to multiply A and B plus C, right? So B plus C is in brackets, and therefore when we have A and then next to it would be B plus C, the operation between them would be multiplication, right? So what we want is to distribute A to B and to C. What it means is that we multiply A to B and then A to C, similarly to what we do with numbers, right? So that we've got AB plus AC. AB means A times B, and then AC means A times C, right? So that's what we call the expanded form, right? And this is the factorized form. Remember that word. Let's have a look at our example here. We've got 3. Why is it not writing? 3 multiplied by A plus 2. We want to distribute the 3 to A and to 2. That what it means is that we want to multiply 3 to A and then multiply 3 to 2, right? And therefore, if we've got 3 times A, that's written as 3A, and then 3 times 2, you get 6, right? Now, what we learned previously was that we can only add these terms if they are like terms. 3A and 6 are not like terms, right? 6 is just a constant, and we would only be able to add it to a constant. 3A would be what we call an A term, and we would only be able to add that to something else that would have an A as well, right? Otherwise, we've got 3A plus 6 as in its simplest form, okay? What it means is that we can't add them anymore, and therefore, that's the answer we are looking for. Next, we now have a variable outside the brackets, and we want to multiply that to x minus 5, yeah? So now we've got x distributed to x minus 5. So we want to multiply x by x. We learned from multiplication last time that we would just have as x squared, right? X times x is x squared. And when we have x times 5, you just have x, 5x, right? Now notice that I've put in a minus there because you've got here a minus as well, right? Notice that in the previous one, we've got a plus 2, and therefore we ended up with a 3a plus 6. If it's a minus here, then you've got a minus here as well. Okay, yeah. Have a few other examples that would have that wherein you would have to expand and simplify, right? So what we want to do would be to expand the first term and then simplify later, right? So when we have that, we would only multiply or distribute the 3 to the ones inside the brackets. When we have 3 times x, we get 3x, and that's a minus, and therefore we've got 3. You could also think of it as 3 times negative 5, and your answer would be negative 15. So when you're adding a negative 15, it's the same as when you minus 15. Okay, and what do you do with 4? You just add the 4 after, right? Now notice that I've got 3 terms here, and I would be able to add or combine the negative 15 and the plus 4, right? Because they are both constants. And when we have negative 15 or minus 15 and we add that to 4, what do we get? When we have 3x minus 15 plus 4, that becomes minus 11, because negative 15 plus 4 is negative 11. And therefore, that becomes minus 11. Let's have example 4. A bit more complicated than the other, because then we'll have to be doing twice the expansion and then simplifying afterwards. Okay, so now we've got this. Let me just make that smaller so we'll have a bigger space over here. So we want 2x distributed to the ones inside the brackets here. And when we have the closed brackets, that's when we stop the expanding or the distributing. Then we multiply this to that, right? So we've got 2x multiplied to 3y. We get, so again, numbers first, then letters when we multiply. 2x times 3y, you get 6xy, right? 2x times 3, you get 6x, right? And then we've got 3x times y, we get 3xy. 3x times 1, we get 3x, right? Now, which ones can we put together or combine? We have here xy. This one's xy. That's also an xy, and therefore we can combine these two. And the result would be what? 6xy plus 3xy. You just simply add the coefficients. So 6 and 3 gives us 9, and therefore that becomes 9xy, right? Next, you'll have 6x and then 3x. And they are like terms because both of them would have an x, right? Now notice when I circled it, I also included the plus or the minus so that I know if it's a positive or a negative, right? So now I've got 6x added to 3x, I have 9x. I've got 9xy and 9x. These two are not like terms, although this has x and that has also x. This has y. So these two are not like terms, and therefore you just leave it as 9xy plus 9x. We've got 4 multiplied to 3x plus 4 plus 7x plus 12. Okay, so the 4 is distributed to each of these, and it stops there because I've got there the closed brackets. Yeah. So now I've got 4 times 3x, that becomes 12x. And then we've got 4 times 4, we've got 16. And then just copy out the rest of the expression. Okay, so now we've got 12x and 7x. We can highlight those two because we're adding them together. 12x and 7x gives us, no, 19x, right? 12x and 7x is 19x. And then we would want to add the constants together, 16 and 12. And now we've got what, 16 and 12? That is 28. And let's have the last one there. We've got 4x multiplied to 2x minus 1 minus 3, 2x minus 1. And we distribute the 4x to each of those. We get 8x squared. Don't forget the squared. So numbers first, then letters. 4 times 2 is 8. X times x is x squared. Okay, we've got 4x times negative 1. That just becomes negative 4x, or minus 4x. Now, this is now the tricky bit, and this is their favorite, I tell you, right? When you have a negative number outside the brackets, you need to be extra careful, right? So what you want to do is to distribute this, not just the 3, but the negative 3. So what it means is that you're multiplying negative 3 to each of these terms. Okay, so you've got negative 3 multiplied to 2x. Numbers first, then letters. Negative 3 times 2 gives you negative 6, right? And then you've got, it doesn't have a letter, and therefore you just put in the x, right? Negative 3 times negative 1 becomes positive 3. And this is a common mistake that students make, right? When they see a minus 3 there, they ignore that, and this still becomes minus, but that's wrong. It needs to be positive, because when you have a negative 3 multiplied to negative 1, it becomes positive. Okay, we want to combine the like terms, by 8x squared, right? And what Daniel said was that we can combine these two. And again, you might want to include the negative there so that you know you're adding negative 4x and negative 6x. That becomes negative 10x, right? And then you add 3. Do you have any questions about the work or the questions that we did, the examples that I've shown you today? No? And if you do, you're welcome to message me, right? Or you can type on our live document. If there are no questions, I'll see you on Friday.